Section 2.4, write and solve inequalities. Our objective is going to be to write inequalities to model real-world problems and use our properties of equality to solve the inequalities, okay? So first we need to talk about what is an inequality. An inequality is just a math statement or a mathematical statement comparing two expressions. So it's comparing them and comparing them mathematically, which one's larger, which one's smaller. Okay, so equalities from, of course, the previous sections have equal signs. Inequalities have unequal signs. And there's actually 4 of them. The first one is the greater than symbol. Okay, or then we have the less than symbol. How I keep them straight is I put dots on the ends and the point. We read math, just in general, English-speaking people read from left to right. Okay, so I always look at with the greater than symbol, 2 dots comes before the 1 dot. 2 is greater than 1, so it's a greater than because it goes 2 dots, the bigger side is first. Whereas the less than symbol, the smaller side is first. The 1 dot comes first, and then the 2 dot. Okay, so we have our greater than, we have our less than, but we also have our greater than or equal to. It has a line underneath it. So this is greater than or equal to, meaning they could actually be equal, or we have, again, less than or equal to. Okay. So there's our 4 symbols. And for the most part, we solve our inequalities the same way. If you notice down here, we have our properties of inequality. We have addition property of inequality, subtraction property of inequality. They work the exact same way. There's really only 2 things that are different. So we haven't talked about the multiplication or division properties because that's one of the things that are different. So the first thing that's different, okay, so let's come over here. What's different about solving an inequality as opposed to an equality? Number 1, okay, flipping it. Okay, what I mean by that is if I have an inequality and so I guess flip it. So basically, if I have an equality that 2 is less than 5, if I want to just flip it over, my inequality has to change direction. Okay. So when we're solving an equality, and let's say I have 6 equals x plus 5, it's no problem for us to flip it over. X plus 5 equals 6. It's really the exact same thing. We just flip the sides. When I'm dealing with an inequality, let's say I have 2x plus 3 is greater, oh wait, let's flip it over. 7 is greater than 2x minus 3. If I'm going to flip that over and put the 2x minus 3 first, the inequality has to flip too. Okay. Just like in this situation, which side is bigger has now flip-flopped. So this inequality sign has to flip-flop. So it's a lot harder just to flip it over. So you have to be careful with that one. And then second is you have to be careful when multiplying and dividing. Okay, so basically that's these 2 steps here. The multiplication and division property of equality, I'm going to put a big star here. The multiplication and division property of equality. Okay, so basically they do a bunch of stuff with these literal equations, okay, because they're using A, B, and C to represent numbers. Okay, so I'm going to explain it, and I think once I explain it, it'll make sense. If I have an inequality, let's say -6 is less than 8, which is true. -6 is less than 8. If I take both sides and multiply by a -2, So I'm taking both sides and multiplying by a negative 2. My left side, which was once positive, which was once negative, is now going to be positive 12. And my right side over here, which was once positive 8, is now going to be negative 16. Does it still work for me to use a less than sign in here? Is 12 less than negative 16? No, because the side that was negative has now switched. So my inequality has to switch. So what's different about inequalities? If you multiply and divide both sides by a negative, this only works when you're multiplying both sides by a negative. Okay? The inequality has to switch directions. The inequality switches directions just because you've just now changed which side is bigger. Okay? So that holds true when dividing as well. Okay, so if I'm dividing, so let's say I have negative 2x is greater than negative 10. Okay, so right now both sides are negative. And so this side is in fact bigger than this one. Our normal situation here is we want to divide both sides by negative 2. But I'm dividing both sides by a negative. So now this right side becomes positive. The left side also becomes positive. So now the side that's bigger isn't bigger anymore. So my inequality has to switch. Okay, so your inequality has to switch directions if you divide or multiply both sides by a negative. Okay. So we're going to be finding solutions to an inequality. Unlike our solution to an equality, previously our solution, so far, our solutions have been one single number. Okay. Like x equals 5, x equals 12. It's one single number. Solutions to an inequality solutions are usually sets of numbers. Okay. For example, in this one I did up here, I solved it. My answer is x is less than 5. That means that as long as I pick a number less than 5, it will work up here. So it has a bunch of solutions. So we tend to graph them. Okay, so if I was going to graph this, what I do is I start with a number line. And I normally mark my border point. So this is like my border point, like where we switch from numbers that work, numbers that don't. 5, and then I normally mark where 0's at. I don't mark all the ticks in between. I don't expect you to. Okay, so there's 0. There's 5. Only the numbers less than 5 will work. So then I look at, okay, which numbers on this number line are going to be less than 5? Well, that is going to be all the numbers down here. Okay, so how do I mark that on my number line? I draw a dot at 5, and then I normally do like a zigzaggy shade going that direction. Another way is to do it above and draw an arrow in that direction. Now, do you notice I didn't fill in my dot? I used an open dot. We use an open dot if it's not equal to, because this inequality symbol was not equal to, meaning I can't actually use 5. 5 won't actually work in here, but anything less than 5 will. Okay. So if we have an equal to sign, like in this next task 2, we have a greater than or equal to sign, we would use what's called a closed dot, where we actually fill that dot in. Okay. So you only use the closed dots when it's equal to. Okay. So we use open dot. So let's do some side notes. An open dot for strictly greater than or less than. And then we use a closed dot. So I'm going to go ahead and draw an open dot, shade that way. We used a closed dot, shade that way, for greater than or equal to, less than or equal to. Okay. Might be important to go ahead and add that onto here. Okay. All right, let's go ahead and let's solve some. Again, we do these the exact same as if we have an equality, except if we have to flip, if we want to flip it over, our inequality has to flip with it. And if we multiply or divide both sides by a negative. Other than that, we solve them just like we've been solving. Okay, so here I want to solve this. So I'm solving this for x. So I look at where my x's are. Ooh, I've got both of them, and there's one on each side because there's my inequality. So I need to get all my x's to one side. I have a 1/2 here, so the first thing I'm going to do is distribute. Okay, justifying my steps. First thing I'm going to do is distribute. So I will have, again, 3x plus 2 greater than or equal to 1/2 x plus 1/2 times 5 is 5/2. Okay. Now at this point, to try to figure out what to do, again, notice where your x's are. They're on opposite sides, so I need to move them all to one side. What helps me when I'm dealing with these fractions is I like to look at, what if this fraction part wasn't here? What would I do? I would take this 1x and I would subtract it to the other side. Okay. Now I can't just get rid of that fraction part. So instead of subtracting 1x from both sides, I need to subtract 1/2 x from both sides. Okay, so 3x plus 2, and then minus or plus a negative 1/2 x. 1/2 x plus 5/2, and we're also going to add that negative 1/2 x to this side. So my 1/2 x is on this side. This guy and this guy are opposite, so they add to 0. And now over here I have like terms, so I need to take 3 and add a negative 1/2. So at this point I can use a calculator. Let's take 3 and add a negative 1/2. What do I get? 2.5. We don't want a decimal. I hit the math button. Enter, enter, 5/2. Okay, so 5/2. Go away. Okay, so on the left side here, I have 5/2 x plus 2 is greater than or equal to 5/2. Again, we didn't do anything where we have to flip our inequality. Now I'm going to subtract 2 from both sides. So 5/2 x is greater than or equal to 5/2 minus 2. So I come back around my calculator. I have 5/2 in there already. I'm going to subtract 2. Enter. That gives me, I can hit my math button. Oh, what did I do? Math, enter, enter. 1/2. Yeah, 0.5 is 1/2. Okay, so is 1/2. And again, at this point, I can be like, okay, if these 2's weren't there, what would I do? I would divide both sides by 5. Okay, so instead of dividing by 5, I'm going to divide both sides by 5/2. And what's nice is my calculator can handle that division for me. Again, so now I'm dividing both sides, so I have to, be careful. I have to come up here and be like, hey, do I have this guy going on? I'm dividing both sides, but by positive 5/2. So I'm not changing which side's positive, which side's negative, so I don't need to worry about that. Okay, so let's go ahead and let's take 1/2 and divide it by 5/2. So I'm going to take parenthesis 1/2 divided by parenthesis 5/2. Enter. 2, which is 1/5. So x has to be greater than or equal to 1/5. So there's my solution. Again, it's a set of numbers. It's all the numbers bigger than 1/5. So we want to go ahead and denote that. So here's my fraction 1/5. 0 is going to be down here because it's positive 1/5. And I want all the numbers, this is greater than. So I want all the numbers greater than 1/5, which would be all the numbers up this direction. So I put a dot. I always leave the dot open to start. Shade this way. And then I am equal to. So I fill my dot in, close dot, because I can equal 1/5. So basically, if I plug any of these numbers in up here, they will work. So a good way to check it is try a number. Go ahead and put a number up here. Let's say 5. Put 5 in to this guy for your x's and see if it works. And I would just calculator it. Take 3 times 5 plus 2. That's 17. That one's not bad. 3 times 5, 15 plus 2. The left side, 17. Okay, what about this side? What about this opposite side? 5 plus 5 is 10. Half of 10 is 5. Okay, would a greater than or equal to symbol work in there? Yep, it worked. I checked it. I checked a number. Okay. All right, next one. Okay, so here we have another one. So again, we need to identify we're solving for x's. Where's my x's? Right there. All right, I've got two of them, but I've got this 3/4 multiplied in front of there, so we distribute. Okay, so negative 4x plus 3/4 times 4. We can calculator that if we need to. 3/4 times 4, which is actually going to give us 3. So we'll have plus 3x. I'm going to rewrite this 12 as plus a negative. So plus, now I need to take 3/4 times negative 12. Again, calculate that. 3/4 times negative 12. We get negative 9. So plus a negative 9 is greater than or equal to 3. Okay. Now, put together like terms. I have two x's. Let's put them together. Okay, make your life easier. Some of us have not been doing that regularly. Always put together like terms before you solve. Negative 4x plus 3x is negative 1x. I'm going to write the 1. I think it'll help. Plus negative 9, greater than or equal to 3. Now to undo, I need to undo this plus 9 plus a negative 9 first. So I'm going to add a positive 9 to both sides. I'm going to leave that as 1x. I'm going to add 9 to both sides. Negative 9 plus 9 is 0. So I'm left with negative x greater than or equal to 3 plus 9 is 12. Okay, now if we didn't put that negative 1 in there, we'd end up at this spot right here where we have negative x is greater than or equal to 12. And it might be hard to like, okay, what do I do at this point? Put that 1 in there. Any negative can be thought of, like even the number negative 8 can be thought as negative 1 times 8. You can always pull that negative off as a 1. So here, because then now at this point, if I think of it as negative 1 times x, I know at this point I need to divide by a negative 1. Then I have x. 12 divided by negative 1 is negative 12. But, notice I divided both sides by a negative. So at that point, my inequality has to flip because the side that was bigger is no longer bigger. So it now needs to become a less than or equal to. I will tell you, at least half of you will probably make that mistake at some point in your homework. So if you are dividing both sides by a negative and it's inequality, your inequality has to flip. Okay. So if we graph the solution set to this, okay, here's my negative 12 because it's on the negative side. Here's my 0. This is a less than or equal to. So I want all the numbers less than or equal to 12. So I'm going to go ahead and put a dot at negative 12. Shade the numbers that are less than that. And it's equal to. So close that dot up. So any number down here will work. I can try a number, negative 15. I can check it. I can put a negative 15 into there. And I can totally use a calculator to do that checking for me. Okay, so negative 4 times negative 15 plus parentheses 3/4 parenthesis 4 times negative 15 minus 12. I can do it all in one step. Enter. I get 6. Is 6 greater than or equal to 3? Absolutely it is. So it worked. My negative 15 worked. Okay. All right, now let's look at an application type problem. We're going to start by setting up a bit of a verbal model. Here we have two newspapers. We have the Daily Info and the Citywide Times. They charge different rates for an advertisement in the paper. Yes, if you want to put an ad in the paper, they charge you money. For how many weeks must an ad be placed in order for the total cost of the ad in Daily Info to be less expensive than the total cost of placing an ad in Daily Times? So I'm trying to find where the cost of Daily Info, again, I'm going to start with the is less expensive than the cost of Citywide. So I need to find what's the cost of Daily Info. So I'm going to go ahead, switch colors. We'll do green. Here, my Daily Info. The setup fee is $650. So I'm paying the $650 regardless. So that's my setup fee. Plus 80, and then they're going to charge me $80 for every week. So plus 80 per week. So if I run the ad for 3 weeks, I'm just again picking some numbers to figure out what to do. It would be $80 times 3. It would be this $80 times 3. So if I did 3 weeks, it would be the $80 times 3 plus that setup of $650. Okay. So if instead of I know 3 weeks, let's say I do it W weeks, it would be 80 times W. So I think I kind of have an equation for my daily info. It's $650 plus $80 times the number of weeks. Okay. Now, purple, citywide times. Citywide times doesn't have the startup fee, but they charge more per week. It's $145 per week. So it'd be $145 per week. So if I run it for 3 weeks, it'd be 145 times 3 or times 5 if I do it for 5 weeks. So if I do it for W weeks, it'd be 145 times W. So I think I have my equation. My cost of my daily info is $650 plus 80 W. And I want to know, when is that going to be less than 145 times W? How many weeks would I have to run it for the cost of daily info to be less? Because just by looking, 1 week at Citywide is going to be way cheaper because it's only $145, as opposed to this one, which is $650 plus the 80 for just 1 week. Okay, so as of right now, Citywide's cheaper. So when is the cost of daily going to be cheaper? It will eventually, because you're getting charged less per week. Okay, so the first thing I'm going to do is I want to solve for weeks. So my W is right here and right here on opposite sides of my inequality. So since I have more W's on the right, because it's 145, I'm going to subtract or add a negative 80W to both sides. Plus 80W minus 80W, or plus a negative, is less than 145W plus a negative 80W. So now these add to 0. I'm left with 650 is less than 145 minus 80 would be 4 and so 65W. Okay. Now we could flip it at this point. I don't think I'm going to. I'm just going to divide both sides by 65, which is nice. 65 divided by 650 divided by 65 is just 10. Okay, so 10 has to be less than W. It is much easier to graph it if your variable's on the left side. So I'm going to flip it over. Again, we have to be careful when flipping. My inequality flips too. So W has to be greater than 10. So more than 10 weeks. More than 10 weeks. If we graph this, here's 0, here's 10. Basically open dot that way. So for anything more than 10 weeks, if I'm going to advertise for more than 10 weeks, then daily info is the way to go. If I'm going to do it for less than 10 weeks, then I should use Citywide. Okay, so more than 10 weeks.